The world is full of sights and sounds and countless other sensory elements that we perceive and use in our everyday lives.
This morning, you might have woken up to the sound of your alarm.
Or possibly slept in until the sun shined through the window.
And then enjoyed a warm, delicious cup of coffee.
Well, imagine a world in which our ability to sense is compromised. Think of how our everyday life would change. Like us, virtually every living thing on this planet uses some set of senses to detect and live in their surrounding environment. Sadly, human activity can often interfere with such interactions, and today we'll look more closely at how we are affecting one species in particular. I'm Kevin.
I'm George.
I'm Allison.
I'm Margaret.
And today we're going to talk to you about the effects of acoustic disturbances on the bottlenose dolphin. Of the 7 billion humans on this planet, many live in cities located along coastlines. Naturally, people who live near water engage in water-related activities. One of these activities is recreational boating, and it has risen in popularity as coastal cities continue to grow. In places where people use boats, there are many ways in which the activity can affect local ecosystems and the organisms that live there. One such organism, the bottlenose dolphin, is an intelligent and highly social mammal that uses hearing for many everyday behaviors. The use of sound, in the form of sonar, is something that is directly affected by the presence of boating vessels. Studies have shown how increased sea ambient noise, or SAN, can have adverse behavioral effects on dolphin populations. On the whole, the understanding of this interaction is a relatively new field of study. How does increased SAN affect dolphin distribution? What are the long-term impacts of these disturbances? These studies help us address these questions and shed light on conservation implications that surround the issue. To help with our approach, we'll use the underlying conceptual framework presented by Berger-Tal et al. Here we can apply it to the relationship between a specific behavior, in this case species distribution, and the anthropogenic factor of boating activity. In reviewing these studies, we hope to illustrate the importance of ongoing efforts to comprehend and, most importantly, mitigate the effects of these auditory disturbances on organisms like the dolphin.
In the first case study, we present a paper by Bejder et al. In 2006. And this is basically a 4.5-year study. And over the years, the researchers investigated dolphins at Shark Bay, Western Australia. During this time, the tourist license went from 0 to 1 to 2, corresponding to an increase in tourism boats, so that with 2 tourist licenses, there are more tourist boats operating. The experimenters set up a tourism site where tour vessels operated predominantly and an adjacent control site where there are no boating activities. They then quantified dolphin abundance and found that as the number of licenses went from 1 to 2, there was actually a 1 in 7 decline in dolphin abundance. Interestingly, there was a slight increase in the control site, suggesting a habitat shifting behavior in which the dolphins leave a disturbed area for an undisturbed one. The study is remarkable to consider in conserving dolphin habitats, as we surely would not want all areas to become disturbed, or else dolphins will become homeless.
In the second case study, we present the paper by Nowacek et al., 2006. The experiment was conducted in Sarasota Bay, Florida, where vessels were directed towards the dolphins and videotaped overhead to examine the behavioral changes. The scientists found that a longer interbreath, which is the interval between surfacing for air, was observed in experienced mothers and females without dependent calves. Other results collected from the experiment revealed increased inter-animal distance, increase in swimming speed, and ultra heading away from the disturbance site. In all, this experiment demonstrates that short-term displacement caused by SAN has a negative effect on the dolphin's behavior. Most importantly, female dolphins face a larger risk of getting struck by boat traffic. Therefore, preventative measures should be taken to promote survival in parenting and survival of these dolphins.
Similarly, other scientists have conducted an observational research in 2011 in the Mediterranean Sea, where bottlenose dolphins are classified as vulnerable. The researchers measured frequency and duration of behaviors such as normal swim, long or short dives, and they found that while sailing boats did not cause any negative impacts when they were close to the dolphins, fishing and power engine boats did, because they have higher sea ambient noise. They found that fishing and powered engine boats negatively affected the dolphins when they were within 200 meters. Dolphins showed more avoidance and stressful behavior in the presence of boats, and they increasingly changed their activities by moving away from the sources of disturbances. Most importantly, dolphins also performed stressful behavior even after the boats had departed, such as faster swimming patterns and shorter dives. They did not appear to habituate to the noises caused by the presence of the loud boats, which suggests potentially negative long-term impacts due to increased sound disturbances caused by boat traffic.
All case studies show that sand does affect dolphin displacement behavior, ranging from long-term behaviors such as habitat displacement to short-term behaviors like longer interbreath intervals and faster swimming speed. Although we cannot conclude that these behavior changes are definitely negative, the fact that these changes exist should urge us to be more cautious of sand's potential consequences. We recommend applying Berger-Tal's framework. The anthropogenic factor is sand. The behavior domain includes the changes in behavior just mentioned. The behavior-based management includes tourism and boating regulation, changing commercial boating routes, and creating designated undisturbed habitats for dolphins. And lastly, the behavior indicators that indicate success of these regulation efforts can include a decrease in habitat shifting and the return of behaviors to pre-sand levels. It would be very helpful to see if changes in behavior correlate to stress by measuring physiological changes, such as the stress hormone cortisol. Future studies should also follow the spatial distribution of different dolphin populations near areas with boating activities to address possible population fragmentation. Dolphins are a marvelous species, and like all other animals, they deserve respect and a peaceful habitat. Thank you for watching, and we hope that you enjoyed this video.